In this video, we're going to look at some of the more complex procedures we can perform in ShaderGraph. We're going to look at how we can use noise and textures as an input, and how we can use them to perform and influence different operations within our shaders. This video is the third part in our series on working with shaders and getting started with ShaderGraph in Unity. The first part in the series covered the very basics of getting started, and our second video covered how we can use operations in a shader to combine inputs for different results. They're both linked in the description below. At this point, we have a pretty good understanding of some of the ways we can manipulate textures and properties in a shader to achieve interesting results on our materials. In this video, we're going to go a step further and look at how we can improve our current understanding of UV's textures and operations to create animated effects on our sprites, and how we can use different noise patterns to influence them. I've put together a small environment here using assets from the Lost Crypt made by Unity. These assets are available for you to use for free and are included in the demo project linked in the description below. One of the most useful procedures we can perform on a shader is to offset the UV of a texture. We can use the tiling and offset node in ShaderGraph to do this. As the name suggests, it allows us to adjust the position and scale of how our texture is rendered onto our surface. By controlling the offset and tiling of a texture, we can design effects in our shader such as tile patterns, transitions, and dynamic animations. Let's explore how this works by creating a new 2D shader. Let's create a new tiling and offset node and hook it up to our color output. Let's then also create a vector 2 called tiling and another vector 2 called offset in our blackboard and assign them to the properties of our tiling and offset node. Then, let's create a material from our shader and assign it to a new sprite. Now, if we change the tiling or offset in the inspector, you can see how we can adjust the positioning of our UV mapping on the surface. If we then assign this data to the UV channel of a sample texture 2D node and the main texture property on our sprite, we can offset and scale the texture of the sprite accordingly. This works well for changing how a tiled sprite looks. Let's take a look at how we can create a simple effect by offsetting the UV of a texture like this. I've created a little doorway with a sprite mask and a gradient sprite as a child. Let's assign the offset material to the sprite renderer so we can control its UV. If we adjust the Y offset in the inspector, we can adjust how the gradient interacts with the doorway. If we scale from 0 to 1, we can create the effect of a beam of light moving along the doorway. And if we change the wrap mode on our gradient sprite to something that repeats or mirrors, we get this cool-looking shield effect just by moving the gradient up and down. If we wanted manual control, we could choose to animate the offset property by code. However, as it might be nice to move the gradient offset continuously, it's cheaper and easier to perform this animation inside the shader itself. The time node in ShaderGraph allows us to sample various points of time data from Unity, such as total time elapsed or time since last frame. If we multiply our offset by time and save our shader, we can now use this property to offset our UV every second by a set amount. We can now choose to animate our gradient gradually or rapidly over time. Manipulating and animating textures by scrolling the UV in this way is a very simple procedure that forms the basis of a lot of the effects you see in games today. Often, many games will simply combine lots of scrolling textures with simple procedures to create more complex-looking effects. For instance, many games will create their water effect this way. Another cool thing we can do to our sprites is offset their position in the world. We can create a positional offset as a property in our shader and add it to the object's current position to move it in the world. This can be perfect for sprites in the background that we'd like to animate, such as these 4 clouds. We can gradually offset their position over time by manipulating their vertex position in the shader. We'll start by creating a new sprite-like graph shader for the clouds called Cloud Offset and a material that uses it. We'll assign it to the clouds. In ShaderGraph, we will add an exposed property called _main_text and connect it to a sample texture 2D node and the master color. Let's create a new time node in ShaderGraph and multiply it by a vector 3 property we'll call direction. Then let's add this value to the object's position. If we set our direction to about 0.5 and hit play, we can see that our clouds gradually move across the sky until they eventually disappear out of frame. This is because their vertex position is continuously being added to. It would look a lot nicer to have the clouds endlessly loop. To achieve this, we first need to limit the distance our clouds can travel. In our shader graph, let's add a new node called modulo. If you're unfamiliar with the modulo operator, it finds the remainder of one number after division by another number. When a number is divisible by the modulo number, the result is 0. So, we can use the modulo operator to clamp our movement distance and make sure that the sprites never move further than a specific distance. Let's create a vector 3 called distance and assign it to our modulo. Now, as our direction vector increases over time, the modulo operator will then return a vector 3 with the remainder values from our distance vector. If we change our distance value in the inspector, you can see that our object will never be able to move further than the distance vector. To create the seamless loop, we simply have to set the distance value to the distance between each cloud sprite. Each sprite is 15 units apart, so we'll set our distance value to 15. Now, our clouds move automatically and loop seamlessly. By combining a noise texture and a scrolling UV offset, we can generate a moving noise texture that we can use to procedurally manipulate different parts of our shader. In the previous video, we showed you how you can use images as noise textures in our shaders, but ShaderGraph also has a number of built-in nodes that generate noise textures for us. Let's create a shader graph and add a simple noise texture node. Then let's hook up a few nodes to allow us to offset our UV position over time. If we hook this into the color property of our shader, you can see that we now have this scrolling cloud texture. Now, we can use this texture to manipulate different parts of our shader. Let's get the texture from our sprite and set that as the color for our shader. Then, let's add the noise texture to the position of our tree. As the noise texture moves, it'll offset the vertices of our sprite and make the tree look like it's blowing in the wind. Noise textures are also a really common starting point for a lot of more complex shader work. Often, great-looking shaders come from combining the results of a lot of different, simple techniques. And hopefully you can see how easy it is to create these basic effects on our shaders, and what we can use as a starting point to create something more complex. In the next video, we'll take a look at how we can combine everything we've looked at in this video to build a cool-looking 2D water shader that animates and also reacts to lighting in the scene. For more information on ShaderGraph and to download the demo project and try it for yourself, follow the link in the description below. Thanks for watching.